without further ado, let's jump right into Houdini. This is what Houdini looks like when you very first open the program. This is its sort of default state. Now, I'm not going to go into great detail on what all of the interface items are. SideFX actually has a massive library of videos to help you get up to speed on all of the ins and outs of the interface of Houdini. But I am going to show you how I like to set up the program. So I like a handful of things. So there's all these extra windows that we really don't need. So I'm just going to get rid of these. And I'm actually going to ditch the parameter window. I'm going to show you how flexible Houdini is to actually set up in the process here, right? So I'm going to get rid of the tree view, and I don't need this, I don't need that. So right now I'm left with my 3D viewport, and this is my node graph area. There's nothing in here at the moment, so nothing to really show, but this is where nodes go when I'm building them. So what I want to do is I like to split this window left and right. So I'm going to go up to this little arrow. I'm going to say, let's see, split left and right, just like that. And then I'm going to split this one top and bottom as well. So I'm going to go over here. I'm going to go split pane, top and bottom. So I'm going to turn off this little pin. We'll discuss the pin maybe a little later. But right now I have 3 of the same window. That's not really very helpful. So what I'm going to do is go up here to the little tab, and I'm going to right click. This one I'm going to make my parameters window. And this one, oops, I'm going to make this one my geometry spreadsheet. So like I said, the geometry spreadsheet, extra node that I don't need. The geometry spreadsheet is super important, and we'll discuss the geometry spreadsheet in depth. So now what I'm going to do is I'm actually just going to go up here. I'm going to say save current desktop as, and we're just going to call this GSG demo. Hit save. There we go. So now I've got this as a preset. The other thing I really don't like is the way that this viewport looks. I just don't really like this sort of like light blue gradient. I like it dark. So with my mouse over the viewport area, I'm going to hit the D key, and that's going to bring up the display options. So I'm going to go over here to background, and I'm going to say color scheme dark. So let's dig into making a really quick demo to showcase the power of attributes before we dig into project stuff. Right now we are at the object level. That's what this is showing us up here. We have no nodes. We have a completely empty node network, and we have a totally empty viewport. So what I'm going to do is hit the tab key with my mouse over my network area. I'm going to hit the tab key, and these are all of the different types of nodes that you can make. When you hit tab, it brings up this menu. So we have a whole bunch of ones here, right? But if I also start just typing, it's going to bring up, it's going to sort of intelligently search through all the nodes that it can make and give me options. And actually the search feature is incredibly robust. So I don't need to be up here. I can just start typing anywhere. And what I want is geometry. And you can see it's got a whole bunch of these geometry things, but what I want is just regular old geometry. I'm going to drop that right here. And it's called Geo1. So this is, because we're at the object level, this is kind of my master comp. This is where if I had lights or cameras or whatever into the scene, this is where they would all go. Right now I'm just going to play with this geometry node though. And this node on the object level, this is kind of like a subnet, right? This is a pre-comp, if you will. So if I double click this, I'm going to jump inside that node, and you can see that right up here. I've got object level, and then now I'm inside Geo1. And Geo1 is, again, just an empty geometry network. There's nothing in here yet. So I'm going to make a grid. So again, I'm with my mouse over this area, I'm going to hit the tab key, and that brings up a whole other list. And you'll notice that this list is actually quite a bit larger than the list that we had at object level, because we can create a whole bunch of different things in here. We are in the SOPs context right now. So we are going to be creating SOPs in here. What I want is a grid SOP. And that does exactly what it says it does. It creates a grid. And you'll see, we have our flags, right? We also have this kind of ring, and you can change the way that this ring behaves. But basically, this ring is like quick access to each of the flags. There's my visibility flag and my template flag, my lock flag, and my bypass flag. I also have this information flag, which I'll discuss in a minute. But the reason that exists is not so much for here, but when you're way, way, way out here, I roll over that and I still have access to that, right? So like I can't really get to those flags, they're so tiny, but out here I can actually get to these things. Now usually what I like to do is I like to have that ring only visible when I'm at kind of medium or long distances. I don't really care about the ring when I'm this close because I can just click on the flags. So if I hit the D key with my mouse over this area, it brings up the view options for this area. And I can go to node size to show ring. So I can actually drag that down. So now I don't have the ring. I can click on the flags, and back here, I do have the ring. So I can click on the ring. It's great. It should also be said that I am working with version 17.5. That is, at the time of this recording at least, that is the latest version of Houdini that I have access to. Here is our grid, right? It's just a simple grid. There's nothing crazy going on in here. So let's look at what's going on. I'm going to roll over my node here, and I'm going to middle mouse. I'm just going to hold the middle mouse button on this, and it brings up this info window. And there's some really important information in here and some information that I've always found kind of superfluous, and really mean anything to me. The things to me that really I pay attention to are this area here. So this is telling me how many points I have, how many primitives, how many vertices, and how many polygons. Now, there is a difference between primitives and polygons, but in this case, not so much. So the numbers are going to be the same. You can see we have considerably more vertices than we do points. And that, of course, is due to the fact that each primitive has, in this case, 4 vertices. So we also have some centroid information that, like, honestly, I don't think I've ever looked at that or dealt with it at all. There's some additional information about time dependency. This is showing me what my attributes are. And right now I have 1 point attribute, and it's P, and it's telling me it's 3 floats, 3 float values that make up the attribute P. It's also telling me a little information about how much memory this is currently taking up, the last cook time, etc. Really, the only one that I'm concerned about up here is this memory. And that's if I'm doing optimization. Houdini has some tools for optimizing workflows and whatnot. That's where this memory thing really comes in handy. But other than that, I kind of ignore most of this information down here. It doesn't really come into play all that often when I'm using the program. The most important stuff is right here. This is the meat and potatoes of this. So this is telling me what I currently have at this point in the node graph. We also have parameters, right? So I've got my grid, I've got it selected. That's what that little yellow outline is. If I click over here, you can see it's not selected anymore. But because I only have one node in here, this is my parameters for my grid. I can tell it to be a mesh or NURBS or Bezier or points or whatever. I'm just going to keep it as polygons. I can also change the size. So we could say, let's make this like 5 by 5 instead of 10 by 10. I can change the center, although usually what I like to do is use a transform SOP instead of changing the center values here. Same with a rotate. I kind of like to use a transform SOP for those basic transformation things. I can change the number of rows. I can change the number of columns, so I can give it more points or less points or whatever. So you can see now I've got 870 points, where before I only had 100 points. So let's take that back down to 10 and 10. Whoops. 10 and 10, please. There we go. Okay. So then we'll look at the geometry spreadsheet and what that's giving us here. So we'll just scooch this up here. Look at this. So right now we're looking at point values. We're looking at point attributes. And we can see here we have px, py, and pz. So of course these are our point values for each of these. And we have a little visualization tool over here where I can turn on a point visualizer. So that's going to show me where all my points are. And I can actually turn on point numbers as well, which is pretty cool. So let's go over here and look at point 0. That's this one right up here. This one, I'm just going to select that. Let's go ahead and actually, we'll just select that point out here. There we go. So we've got point 0 selected. Point 0 sits at negative 2.5, 0 in y, and negative 2.5 in z. So that's our P attribute. We don't have any other attributes, that's it, because we just have a pretty basic grid. Likewise, if I select point 2, this is the values for point 2. So you can see it's storing each of these points in space, right? The next one over here is vertices. So if I select vertices, you can see it looks pretty different. But what we have is this relationship, right? We have, if I turn on my primitive numbers, this is primitive 0 up here. And primitive 0, if I select primitive 0, that is represented by these 4 vertices. This 0 represents the primitive number, and then the number after the colon represents the vertex number. And then this point number attribute, that is telling us what point is associated with that vertex. And that point, all it's doing at the moment is just storing position values. But you can see what it's doing is it's saying these are the 4 points that make up primitive 0. 0, 0 is, of course, point 0, that's up here. 0, 1 is point 1, that's here. 0, 2 is point 11, which is here. And then 0, 3 is point 10. So not only does that tell us what points are in our primitive, but it also tells us what order they draw in. Because if we went from like point 0 to point 11, and then point 10 to point 1, we would have kind of a weird mess where our polygon would actually cross over itself. So this is telling us what is making up our primitive. That's the only thing that we have over here. The next thing we have is primitive attributes. And since we don't have any primitive attributes at the moment, we don't have anything in here. We'll make some in a minute, but for the moment, we have no primitive attributes to speak of. So this list is pretty much empty, with the exception of the numbers themselves. Same thing with the points. Points also have numbers. So these are also attributes that we have access to. Point numbers, vertex numbers, primitive numbers, etc. And then the last one over here is detail. Now the detail one is it's a little bit different. It doesn't store detail attributes on individual pieces of geometry. It stores the detail attributes on the entire object itself. So basically, detail attributes exist only once, where point attributes or primitive attributes or vertex attributes, they will exist for each individual point or vertex or primitive. For this demo, I actually want to get a few more points and polygons going on my grid here. So we're going to set this to a value of 100. Now, there is one interface thing that I absolutely love about Houdini, and I wish that it was in every single program that I use because it's absolutely incredible. And it's a thing called the ladders. What happens is, what I'll do is I'll mouse over one of these channels, right? So these are all channels in here where all the numbers are. I'm going to mouse over a channel, and I'm going to hold the middle mouse button. And what that's going to give me is this kind of incremented ladder. Now I move my mouse up and down to select my increment, all while holding the middle mouse button. If I let it go, it's gone. So I'm holding the middle mouse button. And now if I move my mouse left and right, you can see it's actually changing that value based on that increment. So I'm changing in increments of 1. Here I'm changing in increments of 10, right? So I can do lots of increments there. And then here's increments of 100. So I can really go nuts and potentially crash my computer if I go too crazy with that. But the ladders are absolutely amazing. Same thing with any of these channels. So here we're dealing with size, so it's a float value. So I can go all the way down to like increments of 0.0001, which is crazy. So, you know, it's almost at this scale, it's imperceptible essentially. So I can change each of these individually, or if I mouse over the label for the channel, I can actually change them both at the same time, which is so cool. I absolutely love the ladders. They're just amazing. They're amazing. So we're going to start with a grid with 100 rows and 100 columns, just so we have a bunch of points, right? So we have 10,000 points in this thing. And we're going to create some attributes, and then we're going to use them. Cool. So let's start with, say, a color attribute. So I'm going to drop down a color sop, and I'm going to make this. We're going to select our little widgety here. Let's make this like a. We'll make it red. Make a red color, and you can see. So when I've selected this, I get different parameters. If I select this one, I get the parameters for the grid. I don't have to have my visibility flag on it to select it and change the parameters. So I can still go up here and change the scale and everything, even though my visibility flag is actually down here on the color sop. Likewise, I can select the color sop and I can change all these values and everything. But you can see when I created this color, it's creating it on the point class. I also have access to detail or primitive or vertex or whatever. I'm gonna keep it on points for the moment, and I'm gonna keep the color type constant. So that just means like every single point gets the same exact value, and I can change these values if I want in here, or I can select the color wheel or whatever. But you can see what that's done is it's actually created a whole 3 more columns of data over here on my point attributes, because we're creating color on points, right? So I have CD, I have CDR, CDG, and CDB, right? So red, green, and blue. And of course, I've got a red color, so all my points are going to have a CDR value of 1 and 0 for both green and blue. Likewise, if I middle mouse, here I can see I have CD. It's comprised of 3 float numbers, and it's color. So I have CD and I have P, where up here, if I middle mouse, I only have P, right? So it's just showing me what my what attributes exist at this node, right? So now I've got this color attribute. That's cool. So let's do this. Let's create just let's create a sphere. So I'm going to hit tab. I'm just going to type in sphere. I'm going to make a sphere. We're just going to make a separate object. Now, by default, a sphere is actually a primitive. So if I middle mouse on this, I have 1 point. That's not right, right? A sphere should have more than 1 point. But you can see here, I've got this thing that says 1 sphere. And that lets me know that what I have is a primitive object that likely has some more information buried within it. So I don't really want to make a primitive. I'm going to select my sphere. I'm going to change this parameter from primitive to polygon. And now I'm going to have, 42 points, right? So you can see that I actually changed the way that it looks over here, but now I have access to all of the points themselves. So I'm going to change the scale. I'm going to reduce this down a little bit, and I'm going to change the frequency. So I'm going to give it some more points. We're going to give it quite a few. Now we have 362 points in here, right? Okay, so what I'm going to do is give this sphere its own color. Now, I could hit tab and type in color and grab another color sop like this, or I could select this color sop and I can hold the Alt key and drag it, kind of like you're duplicating a layer in Photoshop. And I'm just going to hook this up just like this. We'll do it that way. So right now, I'm creating point attributes. These are currently red. I don't want to use red. Let's use kind of a cyan, like blue-green color, right? So you can see what I have is kind of this blue-green color where I have green and I have blue, but no red. So no red values, right? And that corresponds up here. So red is 0, green is 0.5, and blue is 1. That's all the values that I have here. Okay, cool. So one of the most powerful things that you can do in Houdini is start to manipulate this data that we've created. So in this case, we've got color data. Now, what if I wanted to take the blue from this sphere and apply it to my grid? I can absolutely do that. I'm going to use something called attribute transfer, or an attribute transfer SOP. So I'm going to type in attribute transfer, and I'm going to drop down this SOP. Now, this SOP takes two inputs, right? And both of them are required. That's what this little red arrow is indicating. If it's not a required input, it's not going to have the red arrow above it. But we currently have an error because this SOP does not have what it needs to actually do what it's supposed to do, which is to transfer attributes. So what I'm going to do is roll over this first one, and you can see what it says is this is down here at the bottom. Now I can't move my mouse very well because otherwise it's going to go away, but down at the bottom of the network view, it says geometry to transfer attributes to. This one is geometry to transfer attributes from. So what it's doing is it's going to take whatever attributes I determine I want to transfer from this side and apply it to this side. So we're going to take our color, we're going to feed it into here, and we're going to take this one, we're going to feed it into here. So then I'm going to hit my visibility flag on this, and we're going to see what happens. Boom, there we go. So now I've got a blue grid where before I had a red grid. So it's taking the color from my sphere and it's putting it on my grid. Cool. But there's more. So in the parameters window for my attribute transfer, the first thing that you see here is the attributes to actually transfer. And right now it's transferring basically all the primitive and all the point attributes. Well, I know I don't have any primitive attributes, so I'm actually just going to turn that checkbox off. And right now it's transferring all my point attributes, which really in this case is just CD, it's color. I can tell it to match the P attributes, but things are going to look pretty funky if I do. So we're going to tell it not to do that. But I can specify exactly what attributes from the points I want to transfer. And if I go over to this little arrow here, it's going to give me the options that I have for point attributes, which is color or position. I'm just going to tell it to just transfer color, just in case later I decide to make a whole bunch of other attributes. I don't necessarily want them all transferred. Okay, so now we're just transferring color. The other thing we can do is come up here to the conditions tab, and we can make some adjustments here, because what it's really doing under the hood, it's not just saying all the points get all of this color. It's transferring the color from the sphere to the grid based on distance. So I could actually turn that off, and now it's literally just giving all the color to all the points. But if I turn this on, like it's on by default, I can actually adjust this value, and when I do, you can see what it does. Is it's giving me a radius of effect, right? So I can keep those values really hard like they are now, or I can change this blend width and it'll actually give me like a nice soft feathered edge, which is super, super cool. So now I'm transferring this blue from my sphere to my grid based on distance from the points. And I can actually, if I turn on my template flag, which is this flag kind of next to the visibility flag, if I turn this on for my sphere, I can actually kind of ghost my sphere in there and I can see where it's sitting in space. So because this is based on distance, of course, I can move my sphere around and it's going to transfer all my attributes. So I'm going to throw in a transform SOP. I'm going to throw that in right between my color and my attribute transfer. So I can just grab that and just pop it right in there. I'm going to put my template flag on my transform SOP now, and I'm just going to change some of these values. So the transform SOP is what you use to do things like translation, rotation, scale, etc., right? So I'm just going to start moving it around, and you can see what it's doing is it's continuously transferring those attributes based on wherever my sphere is. And if I push my sphere too far up, now it's outside of that area of effect because the attribute transfer is based on distance. It's now too far away, so it doesn't do anything. But you can see as I push it back down, you can get this. You can kind of see this area, this sphere of effect, which is really cool. Okay, so let's do something a little different with attribute transfer. Right? It's fine to transfer colors back and forth and everything. That's cool, but let's do something totally different. So I'm actually going to jump back out to object level. I'm going to turn off the visibility flag on Geo1, and you can see that when we're out here at geometry level or at object level, we only have 2 flags on these. This one is the selectability flag. So if I turn this off, I can no longer select this object. If I turn it on, now I can select it again. So it just prevents you from accidentally selecting things in the viewport you may not want to. And then this, of course, is the visibility flag. So I can just turn that off because I don't need that on right now. Okay, so we're going to make another geometry node. So I'm going to hit tab with my mouse over here. Type in geo, do geometry 2. This one I'm going to rename this to color transfer demo, so we know what that is. And then I'm going to jump into Geo2, so you can see that's where we are right here in Geo2. And again, I'm going to create a grid. Make a grid. We're going to keep this one default 10 by 10 size, but I am going to give it 100 by 100 points, so it has plenty of points. And again, we're going to create our sphere. We're going to do basically what we did before. Look at our sphere. We're going to change it from a primitive to a polygon, and we're going to shrink it down a bit. Stay there. And then we're going to up the frequency a little bit as well, so we have a bunch of points on there. So let's play with a poly extrude. We'll do a poly extrude SOP on our grid. So we're going to select our poly extrude, and poly extrude does exactly what it says it does. If I change this distance parameter, it extrudes those polys, right? Extrudes them up or down or whatever I want to do. Right now it doesn't have a backside, right? So it's just sort of an empty box, but if I turn on output back, it'll output a back as well, or I can turn off output side or output front or whatever if I want to just isolate one aspect of this, but I want to just keep it box, just like that. Cool. Now, one of the things, if I go back here and I turn off output back, you can see right now it's outputting all of that entire face, that entire grid as a single face. If I go up to divide into, right now it's connect components. If I set individual elements, you can see what it's done is it's extruded each polygon individually, which is kind of cool. And I'm actually going to leave that on for the moment, which I'll explain here. That'll be fairly obvious here in just a minute why I'm doing that. So there's a couple other parameters in here. There's inset, so you can change the inset. And that basically, right now what I have is instead of little boxes, I have little spikes, right? So the inset changes the, basically allows it to scale down the extruded face. In this case, it's the end. So I don't want any inset. I'm just going to leave that at 0, but that's what that does. Twist, pretty self-explanatory. It actually twists as it extrudes, so you twist things. And then divisions basically tells you how many divisions along the extruded side to divide it into. We're just going to leave that at 1 for the moment. Okay, so what I want to do is I want to go up under this local control tab. Now this is something pretty specific to polyextrude. Not all SOPs have this, but polyextrude happens to have it, and it's pretty handy. And I can turn on this distance scale local attribute. I'm going to turn that on, and it's letting me know that it's looking for an attribute called Z scale. And what we're going to do is we're going to create this Z scale attribute, and we're going to use it. So we can create attributes in a few different ways, but a really easy way to do it is to just use an attribute create SOP. Does exactly what it says it does. I'm just going to plug that in right here below the grid. And I'm going to change the name to scale, of course, all lowercase. We're creating this class, we're creating this on the point class at the moment, so this is going to be a point attribute, as you can see here. It is currently a float, which we're cool with that, but we could change that to an integer or a vector or a string or whatever. Anyway, we're going to leave it as a float. Precision, it's fine. It's either 32, 8, or 16. We're going to leave it 32. And we're going to leave everything else in here alone. Now, because this is a float attribute, it only is going to pay attention to the number that's in the first value here, this first channel for value. It doesn't really care about these. Like I can put, I can put like 500 over here and it doesn't change anything over here. It doesn't care. Because it's a float, it's ignoring these. So this number, if I made that 500, you can see it's changed it down here. So I'm going to leave this as 0 for the moment. And what that's going to do is it's going to basically tell Houdini not to do any extruding at all. So now I'm going to take this attribute create. I'm going to move it over here. I'm going to alt drag it, and I'm going to connect the node connection to my sphere. We're just going to look at the sphere now. So this one I'm going to change to a value of 1. So the sphere has a z-scale value of 1. The grid has a z-scale value of 0. And polyextrude is going to use that z-scale value to determine how far each of these little things is going to extrude. And you can imagine where this is going to go. What we're going to do is attribute transfer these. We're going to throw in an attribute transfer. It takes the two inputs, right? So it's geometry to transfer to, geometry to transfer attributes from. So we want to go to the grid from the sphere. We're going to look at attribute transfer here. Now I'm going to turn off primitives because we don't have any primitive attributes to transfer. We just have point attributes, and I just want to transfer z-scale. I'm going to turn that on. Cool. Now, z-scale isn't an attribute that I can normally visualize, right? Like, it was one thing to visualize color because color is a built-in thing in Houdini, and I can visualize color very easily. But I like to see what my attribute values are. And for that, I am going to use a color sop, but I'm going to change some of the parameters on this color sop. So I'm going to plug this in to my attribute transfer, and I'm going to move the visibility flag here. Now, by default, of course, this has just created a blanket color across all the points. But what I want to do is I want to see what the value of this z-scale attribute is. So I'm going to go back to my color sop, and I'm going to change the color type from constant to ramp from attribute. And that's going to give me this attribute field. The attribute I want is z-scale. And it's going to map from 0 to 1, which is fine because I either have a value of 0 on this side or a value of 1 on this side. So it's not going to be, it's not going to all of a sudden be 5,000 or something like that, right? And we know that by default, attribute transfer, if I go under conditions, its distance threshold is really, really high. It's 10, right? So my grid is 10 by 10 and my sphere is in the middle. So really that sphere is like, its influence is reaching all the way out here to like a value of 10, right? My grid isn't that big, so I'm going to reduce my distance threshold, and we should see, yep, there we go. We're seeing what we are, what we're looking at here is this z-scale attribute, right? And it's because, of course, we've got our color sop. If I go back up here to attribute transfer, you can't see anything. The color sop is what's allowing me to visualize the value of z-scale. And it's just creating a gray value, of course. It's just taking the float value and mapping it to a ramp. And I could change the color of this ramp if I want to. I'm not going to do it at the moment, but you can change the color of these knots in our gradient. Really, it's just a visualization tool for me. So I'm going to leave all of this alone, and I'm going to take this and I'm going to plug it into my polyextrude sop. And let's keep the color. We'll plug the color in as well, and we'll go to polyextrude. And what we're going to get is nothing. Nothing at all is happening here. And the reason nothing is happening is because What the polyextrude SOP is looking for is a polygon or a primitive attribute. What we have is a z-scale attribute that's on the points. I need to get it over here to the polygons, right? So what we're going to do is we are going to promote that attribute from point level to primitive level. And what I'm going to do before we do that, I'm going to pop over here to Photoshop and I'm going to just discuss very briefly the concept of promoting attributes. So promoting basically means what we're going to take an attribute that's currently on the points, which are here. So we'll give these, just some value. We'll say, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, and 0. Right? So these are the values that my points currently have on them. So if I want to, instead of having these on the points, I want these to be on the primitives, which are here in the middle, you can see we're going to have a little bit of a problem. The problem is that, for primitives like this, when I take the value that currently exists on all 4 of its points and I promote it to the primitive level, that's easy. It's just going to be a value of 1. Same thing here, same thing here. I'm going to promote that value because all 4 of its points have a value of 1. It's going to say, okay, you're 1. But what do we do for things like this one over here? This primitive up in the corner, 2 of its points have a value of 0, and 2 of its points have a value of 1. There can only be 1 attribute value for a primitive. So which one does it take? The answer is it depends on how you set up the attribute promote SOP. So by default, it's going to take the average, which in this case would be 0.5, right? Because we have 2 zeros and 2 ones, it's going to take the average of that. That's going to be 0.5. You can tell it to, instead of taking the average, you can tell it to take the maximum value. So basically the largest number, which in this case would be 1. You can tell it to take the minimum value, which in this case would be 0, right? But it can't take all 4 of those numbers. And there's actually some fun kind of tricky things you can do with using attribute promotes to do some basic calculations for you. But in this case, it's just a little, it's a good opportunity to explore this idea of moving attributes from the points to their respective primitives, right? So back in Houdini, we're going to throw in an attribute promote SOP. And I'm going to do this above the color. And we're gonna look at the color SOP really quick. I'm going to ignore polyextrude for right now. We're going to look at the color because what I want to do is show what happens, especially on these primitives. So you can see, here, get rid of that. You can see on primitives where all 4 points have a value of 1, you just have a white primitive. But on some of these primitives, we have values of 1, but we also have values of 0. So it's kind of created this little gradient for us because each of those points has a different color value. Now, if I go to attribute promote and I tell it the original class is point, so that's where it's coming from. The original name, of course, is z-scale, so we're going to take z-scale and we're going to promote it from the points to the primitives. And the promotion method, so you can see immediately everything has disappeared because this color SOP that we're looking at is looking for a point attribute called z-scale. That doesn't exist anymore. It's been moved to the primitives. So here it is sitting on the primitives. So if I change on the color SOP, if I change it from a point class to a primitive class, there's my primitives, right? And you can also see what's happened is each of my polygons or primitives, it's gone solid. It's no longer that gradient that I had before because there's only one value for primitive. And now that's what we're looking at. So it's not trying to do any kind of like weird interpolation between the points on a single primitive. It's just giving me one color for each primitive. Okay. So Z-scale is currently set to average. And I'll keep the promotion method average, but you can also see here we've got maximum, minimum, mode, median, sum, etc. Right? We're just going to keep it average for the moment. You could also rename the attribute as you're promoting it, which is another thing that we'll do later, but that's a pretty handy thing to do. Okay, so now we've got all of these attributes. Now remember, this isn't a color attribute, it's a Z-scale attribute. That's the thing that really matters. The color SOP is just here to help us visualize it. In fact, I'm going to turn it off by hitting the bypass flag, the flag furthest to the left. I'm going to turn it off. You can see Z-scale is still there, but we're turning off the visualization on the color SOP. Okay, so let's finally select our polyextrude SOP and see what it does. Boom, nothing. And that's because this distance is acting like a multiplier. Now, if I push this up to a value of 1, this is multiplying whatever this number is times Z-scale to give us the amount of the extrusion. And you can see exactly what that's doing is it's extruding. Now, if I turn the color SOP back on, it'll make a little bit more sense why we have some of those polygons that are sitting a little lower than some of the others, because you might expect them to all sit at the same height. If I change the promotion method from average to, say, maximum, now they all sit at the same height, because for each primitive, it's taking only the largest point value, which in this case would be 1. Likewise, if I change this to minimum, you're going to see it shrink down just a little bit, and that's because it's doing the opposite. It's taking the 0 instead of the 1. If I do the average, we're going to get grayscale values. We're going to get values that go to 1 and values that have 0, but then we're also going to get some kind of float values in between. And I can really see that if I go back up to attribute transfer and I change this blend width, and I start to blend that out, and I reduce this distance threshold, you can see now we're getting lots of values that are either 0 or 1 or some gradient in between. So we're getting all of these here, of course. And now the nice thing is, if I throw in transform SOP up by this sphere, now I can move that sphere around. If I template it, you can see where it sits. Well, you can't really, it's under there, but it exists. And now I can move that sphere around, and it moves the area where everything is extruded. And you can see that happening really nicely here. Cool. So before we continue on with anything else, I do want to touch on just a couple of things that are directly relevant to what we have going on here, and specifically around where I put this transform SOP, because where you put things totally matters. As data processes in SOPs, at least, it processes from top down. So you can see we've got the grid, we create an attribute, we have a sphere, we create an attribute, we transform it, we transfer the attribute, we promote the attribute, we color it, we polyextrude, and then we're done. So we go from top to bottom. There's a very clear flow to the way things work. So if we had this transform SOP, if we had it somewhere else, I'm going to take this, first of all, I'm going to take this SOP and I'm going to remove it. So Houdini has a kind of a fun functionality for removing nodes that are in the middle of a data stream like this. If I just grab the node and I shake it, it'll pop right off of there, which is kind of cool. And I can just put it right back. The UX in it is absolutely fantastic. So I'm just going to shake that off of there. If I say put this transform SOP over on this side, and I put it on the grid, now what's going to happen is the grid is going to move instead of the sphere. So the sphere stays in place, but now I'm moving the grid around, right? So where this transform SOP goes really matters. So likewise, if I put it underneath the attribute transfer, now I'm moving everything, right? Because I'm moving it after the attribute has been transferred. So it's not doing the same thing anymore. That's a really important distinction to make as you're learning Houdini and you're learning the way that the data flows through the system. Knowing the order of events to get the desired effect that you have, very, very important. Okay, so another thing that I want to play with here is I want to show you the groups. So if we go up to our grid, let's go all the way up here. Let's go ahead and let's drop down a, let's do a group SOP. And I'm going to put that in right here. So a group SOP, it takes two inputs. The first input is the source data to group, in this case our grid. The second input is a potential bounding object. Let's do a torus. Nope. Helps if I can spell torus correctly. There we go. So let's throw a torus in here. Let's just template this torus. Let's look and see where it's at. Let's change the radius. Let's make it a little bit wider and then maybe make it a little thicker like that. Okay. So we're going to take the output from this torus and we're going to plug it into our group, and we're going to build a primitive group based on points that fall within this torus shape. So I'm going to select my group SOP here. We're going to put the visibility flag on it. And you can see at the moment, all my primitives have turned yellow. And if I middle click on this, you can see I've got a primitive group called group 1. That's just what this is called by default. And it has 9,801 primitives in it. Now I have a total of 9,801 primitives, which means that all my primitives are currently in the group. So what I'm going to do, first of all, I'm going to change this group name to, we'll call it area group. I don't know, why not? So you can see that's changed it down here. What I'm going to do is I'm going to turn off this. I'm going to disable this. So now none of the groups in there, but I'm going to turn on keep in bounding regions. I'm going to turn this on. And by default, it gives me a box. And I can change the size of this box. I could make this a bounding sphere. So now it's giving me a sphere. And you can see that only the primitives in that sphere are actually in the group. And I can demonstrate that if I middle mouse this. Area group is only 1,397 primitives out of a total of 9,801. So that's something I can do there. Now I can move that around using the center options here if I wanted. But what I really want is everything that's in that torus. Now I have to have that torus plugged into the second input of my group SOP here, but I'm going to go to bounding type and I'm going to say bounding object. And it's telling me that it's only going to activate on points or vertices only. That's it. So now it's thrown me an error. It's getting angry because selecting bounding option only works with point groups. So if I middle mouse on a node that has an error, it's going to tell me what that error is. So it says that I can only do a point group with this. Okay. So we're going to change the group type from primitive to points. So now you can see all those points that lie within the torus, they're now in the group. If I middle mouse, you can see I now have a point group called area group. It's got 2,624 points out of 10,000 points. Okay. Very cool. But that doesn't really help me because if you remember down here, the poly extrude, it wants primitive stuff. It doesn't want point things. So what I need to do is throw in a group promote, because groups again are they're just attributes, and I can actually show you that here. So if we look at our point attributes, this is a group, and it's either going to have a value of 0 for points that are not in the group, and a value of 1 for points that are in the group, like these here, right? So group promote does the same thing that attribute promote does, except it does it with groups. We're going to go to group promote. We're going to say convert from points to primitives, and the group name is area group. There we go. So now all of those points that were in that group, all of their respective primitives are now in that group as opposed to the points. So I no longer have a point group, I have a prim group, and it's called area group, right? There we go. So let's see what happens down here if I go to the poly extrude and I put area group up here in the group field. Ooh, just like that. Look at that. Only the polygons that are in that group are being affected. So if I move my sphere around, you can see these points that are out here, I'm sorry, these primitives that are out here that are no longer in that group are not being affected by the poly extrude. Only the primitives that are in this group. So incredibly handy tool. Really, like, groups are an essential workflow to working with Houdini. Really, really powerful. One more thing before we leave this little example that I've got. I want to talk a little bit about randomizing these values. So in order to do that, I'm actually going to untemplate my torus, and I'm actually just going to get rid of this group in my poly extrude SOP so that we're back to this right here, right? Okay, so right now we've got this really smooth gradient from 0 all the way up to 1, and that's creating this nice little plateau that we've got. But it's not very interesting. We could do a lot more with that. So we can randomize numbers in Houdini in a few different ways. One of the ways we could do is just use the attribute randomize SOP, this guy here. We can take this, we can plug this right in below the attribute transfer. Now it's going to make everything look crazy, and that's because by default it's set to randomize color, or CD. We want to randomize Z-scale. And again, that's going to make everything look really crazy, of course, because it's set to this operation set value. I don't want to set the value. That's going to overwrite what I currently have. I want to multiply the value. So what that's going to do is it's going to take the existing value and multiply it by whatever this randomized number is. So out here, where that value is 0, of course, anything you multiply by 0 is 0. So we're not going to see any effect here, but we're going to see it all in here. And of course, as I move this around, you can see that, whoops, that randomization kind of travels along with the transfer, which is pretty cool. That's fun. Now, speaking of where we put these nodes, the reason I put this down here instead of up here is because the values that I want to randomize are actually down here. If I took this attribute randomize and I shake it off of here and I put it up above on this, we're going to get something that looks very different. We're going to get this kind of weird kind of radial pattern. And the reason we're getting that is, remember that this stream up here is actually operating on a sphere. So what we're randomizing is values that live on a sphere, not values that live on this grid. So when we're randomizing those attributes, the result of that is that it's transferring based on that sphere. So we get this kind of radial pattern, as opposed to when this is down here, it's going to behave a little bit more like how we might expect it to generate random numbers, right? Cool. Well, another way we could generate some random numbers, if we just bypass this, we just turn that off, go back to our regular old boring plateau shape, we could generate random numbers in a VOP. Now, I had talked a little bit about VOPs in the intro to this course, but if we drop down an attribute VOP, that's this node here. What VOPs is the a visual way of programming VEX code. And VEX, like I said, is Houdini's built-in programming language. But if you don't want to program a bunch of code, you can actually do many of the operations visually using a VOP. And VOPs are very similar. VOPs are very similar to the way that something like Espresso works in Cinema 4D. It's far more robust and I think a lot more intuitive, but it'll look relatively familiar to you. So we're going to take this attribute VOP and we're going to plug it in. But before I do, I just want to make a mention of the fact that this has 4 inputs as opposed to 1 input or 2 inputs, right? When you see something with 4 inputs, you always want to plug into the leftmost input first, input 1. So we're just going to take this and we're going to drop it right in here, just like that. Cool. So we're going to hop in and we're going to talk about VOPs. Now, an attribute VOP, you can see the node looks a little different from the way these other ones do. These other ones, they all have just a single plane. The VOP actually has this kind of like stacked look to it, right? And that lets me know that there's actually more inside there. So if I double click on my attribute VOP, it takes me in here, and you can see I'm inside my attribute VOP now. And this is the VOPs context. The VOPs context obviously looks considerably different. It has considerably different functions. So when I hit the tab key over here, I have a whole bunch of different options, completely different from the SOPs context. And what I have here is these are all my global inputs. These are just attributes that I have access to. Now it should be said, if I jump back up, I am running this VOP over points, but I could run it over primitives, vertices, numbers, detail, etc. We're going to keep it at points, and I'm going to ignore the rest of this. So what this does is it runs whatever is in here over all of the points in the geometry every single frame. So whatever is happening in here is going to happen on all the points basically simultaneously every single frame. And what we have here is all of our various global inputs. And these are just the default inputs that Houdini gives us. You can recognize some of them right off, I'm sure. So there's P, there's CD for color, there's N for normal, there's UV for V, obviously. But then there's other things like V for velocity, there's force, there's age, life, ID, etc. Now, we don't actually have most of these on our points. All we have is P, which of course is up here, and we have Z scale, which is nowhere to be found. Well, I don't have a Z scale in here anywhere. I can make a Z scale input, which I'm going to do by using a bind VOP. I'm just going to stick that down here. And by default, the bind VOP is it's set to just this default parm thing. So I'm just going to put in Z scale. And that's going to give me basically a Z scale input because it's not up here in this list. And it is a float type, so I don't have to mess with that. But you can see there's a whole bunch of different types that could be. I'm going to leave that as float because it is a float type. Cool. We do have a handful of things here that are more tied to some root level Houdini functionality: time, frame number, point number, primitive number, etc. And then these down here, these op inputs, these are these 4 inputs up here. So 1, 2, 3, and 4. So if I had geometry coming into input number 2 or geometry coming to input number 3, I could access those things down here in the VOP, right? We aren't going to mess with those for right now, but that's what those are. On the other side, we have outputs. So these are our default global outputs that Houdini gives us access to. We have position, velocity, force, color, and normal. And of course, we can output many other things. We don't have to just stick with those outputs. So what I'm going to do, I want to output Z-scale as well. I want to use this VOP to input Z-scale, do some things, and then output Z-scale again. So I don't have Z-scale up here, so I'm going to have to create an output for Z-scale. I'm going to use a bind export node. And it's literally the same thing as bind, except it's got a little input on this side. So things flow in VOPs from left to right. So inputs, outputs. Same thing over here. So these are the inputs. This is an output. So I want to make sure to also set this to be outputting scale, just like that. So if I just take this and I plug it right in here, literally no difference. If I ran, let's do like a simple operation, like an add. So if I take an add and I throw that in between, right now it's not adding anything because it just isn't. There's nothing for it to add. So what I need to do is, what I'm going to do is middle click on input number 2, and that's going to bring up a little menu. And I'm going to say, give me a constant value. So it just creates a constant node, or I could just hit tab and create a constant node myself, just like that. There's 2 different ways to do literally the same exact thing. So right now it's adding 0. If I set this to say 1, now you're going to see it added a value of 1 to all of that, right? So everything gets pushed up by value of 1. So it's taking zscale in through the bind node, it's adding a value of 1, and then it's outputting zscale through the bind export node, and this is our result. So we can actually use this to generate some additional noise. Now, if you remember, with the attribute randomize, we had to multiply our zscale value by our noise in order to get something that looked nice. So I know I'm going to want a multiply VOP. I'm just going to throw in a multiply VOP. Now, what are we going to multiply this with? We're going to multiply it with a noise value. And Houdini has a ton of different noises. If I just type in noise up here in my tab menu, you can see all of these different types of noise that Houdini has built into it. I'm going to use the turbulent noise because I like turbulent noise. I'm going to throw this in here. So the turbulent noise takes several inputs. I don't have to use all of those inputs if I don't want to, but it takes several different inputs and it has one output, and that's noise, right? Let's look at some of the parameters that it has over here. So signature 1D noise, that's this right here. I can change this to a 3D noise, and now it will output noise in 3 dimensions as opposed to just a 1-dimensional float. There's noise type, which is, it has all of these different types of noise that I can throw in here. Position, we'll mess with that in a minute. There's frequency, offset, you can see all of those are also represented here. So I can pipe in any value I want from any other value into this noise to change things up, right? Cool. So before we continue, I do want to address some of these colors that we're seeing on these inputs, and likewise some of these over here. They aren't just arbitrary colors. They actually do have a very specific meaning. So you can see there's kind of this light green, there's a slightly darker green, there's this blue, and then there's this kind of like salmon color here. So this dark green value, these are for vectors. So position, velocity, force, these are all vector values. Things like age and life and amplitude and roughness and time, these are all float values. So it wouldn't make sense to have time represented as a vector. There's only one value for time, not 3. So the blue ones down here, these are integer attributes. So ID or point number or vertex number. You're never going to have like a primitive number that is a decimal point. It's either going to be, it's always going to be a whole number value. So the blue ones are integers. These salmon color ones, like I said, these are kind of special cases, and in this case, they're representing inputs of our VOP here. But you can see also here, this one also shares that kind of salmon color, and this one is this noise type. So it's not really a numerical value, it's kind of a special case value. So that's what those are. And that's why they're colored that way. So you can see if I look at my noise output here and I change my signature from 1D to 3D noise, you can tell, maybe you can tell, there's like the subtlest color shift from a slightly light green to a slightly darker green that takes place between there. Okay, so let's get this noise involved in the situation here. What the turbulent noise really wants is position. It wants to know what the position is because it's going to use that position number to generate our noise. If I just take this without plugging it into anything and I just multiply it in, it'll do stuff. And I can offset this value, and it's going to offset in space, right? I could also offset the position. You can see it's generating some noise. But it's not really doing much. What it really wants is position. It's going to use that position to generate the randomness. So I'm going to plug P into position, and that's going to give us something that looks much more interesting. That looks far more like noise. Now I can offset this noise, and you can see as I do, that's literally pushing that noise through space, which is really cool. I can offset it in Y as well. I can offset it in Z, and that creates some really interesting looking things going on there. So I can also change the noise type. So right now it's by default set to alligator noise. I could do like a simplex noise. That's going to give me a completely different kind of noise. I could do like a sparse convolution. That's going to give me positive and negative values. So now I have values that are dipping below, which is kind of cool. I'm going to stick with alligator noise though. Alligator noise is a nice simple one. So I can change the amplitude. Of course, that's just going to change how much value the noise has. I can change the roughness. So more roughness equals more kind of peaks and valleys. Less roughness equals less peaks and valleys, or more simple noise. So I'm going to keep that right around the middle. I can change the frequency. So the frequency, of course, just changes the scale of the noise in a way. So you can see as I reduce the frequency, those peaks and valleys get bigger. As I increase the frequency, those peaks and valleys get smaller, right? Which is cool. So if I jump back up to SOPs and I grab my transform SOP and I start pushing this around, you can see that it does much the same thing as the attribute randomize did, where it's kind of, the noise is just sort of existing. It exists in space, and it's almost like we're using that attribute to reveal that noise, which is pretty cool. We can also change this noise over time. So we could take time, we could take the output from time and plug it into like offset, for example. And now, if I hit the play button, you can see that this is kind of undulating and changing over time, which is really cool. Likewise, if I hold down the Y key, I get these little scissors. I can actually draw a little cut through that, and that's going to cut it out. And now if I hit play, nothing. No difference, because time is no longer being factored into this. So what we're doing is we're taking this noise and we are multiplying it against z-scale, and we're outputting the result of that. So if I took, say, for instance, the output of this noise, and I just output that as z-scale, that's gonna generate noise for everything, right? So it's basically overwriting whatever my z-scale attribute was coming into this thing. It's just saying, forget it, we're gonna throw it out, and we're gonna overwrite it with this noise value. So I can show you what that looks like as we kind of change the frequency, and if we connect time up to this, we can see that kind of moving through time as well, which is pretty cool. That's great. I am going to go back to my regular multiplied value though. Let's see. Great. So there's a couple different ways that you can generate noise. Now, with this attribute VOP, we can actually do all kinds of different noises. We aren't just limited to one noise. We could stack noises. We could multiply in different noises. So this time I'm going to duplicate my turbulent noise VOP. And maybe this time we'll use like a sparse convolution and we'll up the frequency a whole bunch. And we'll just take this and we'll multiply it in there as well. So now we've got this being multiplied in there. Let's reduce our amplitude a little bit on this guy. And I don't know, maybe we do a simplex noise or something. We're getting very, very small values in here, and it's because this amplitude has gone down considerably. So we can increase the amplitude of these things. And now if I hit play, you can see I've got kind of multiple noises going on. So we could, maybe what we could do instead of multiplying is we could add these together. We could add the values of these noises, and instead of multiplying by z-scale, we could take the output of this and we could multiply that. There we go. That's something totally different, right? So we have now two noises that are being added together, and they are being multiplied against z-scale. So that's an introduction to noises and VOPs as well. Now, the really cool thing about this is that because this is entirely procedural, I can do fun things like let's drop in a torus SOP up here. I'm just going to template it so we can see what it's doing. Let's make that a little bit bigger. Let's add a bunch more rows and say like 80 columns, just so we have a whole bunch of points in there. And let's take that torus and drop it in right here. So now I literally have the same exact thing, except it's affecting my torus and not my grid. That's pretty cool. And again, I can just move my sphere around. You can see everywhere where it's transferring those attributes, we're getting that really crazy extrusion. And because it's all animated through the attribute VOP, now it's actually animating.